Hello everybody, it's been a while. I haven't made a video in a long time. I recently started my new channel Unicast, but this is German only, but I thought this one might be of interest for a broader range of people. So what's this about? It's called nftwall. I created this, I am creating this. It's still in early stages of development. And I'm gonna describe to you what this really is. nftwall is supposed to be a kind of firewall solution, but especially for environments that are strongly automated. That's why I chose Ansible for a configuration management tool, and I'm aiming to make this a collection. Right now it's just a bunch of different Ansible roles I published also on GitHub and on Ansible Galaxy. But I aim to make this a collection so you can just check it out and go on with it. This nftwall, as the name might suggest, is based on nftables, which is the successor of the IP tables solution in Linux, in Linux. I don't know how to pronounce it for you guys. Anyways, I chose Alpine Linux, very slim, it's fast. I also might develop the Ansible roles further so they support other distributions. I don't know exactly. Some of the roles already do support, like Debian, but it depends on how much work will go into this. The firewall itself will of course support IPv6. In fact, it will default on IPv6. Of course, I support IPv4, which I call a legacy protocol, too. I concentrate on IPv6 because this is the future and you people should dive into it. Okay, what can I show you? I mean, I set up something already and I would like to show you how this might work. So we switch over to my Proxmox. All right, this is my Alpine installation, which I want to be a firewall. I will start it up, and I prepared it already just so I can hit Ansible with it. I gave it a static IP address, and I installed Git, and I installed my public key. On top of that, here is some client, which is Debian. I show you my firewall's network configuration, so you can see that, oh, this is wrong, hardware. This is my public, this is my internet interface. It's ETH0 in the end on the firewall. It's VLAN tag 53, and for clients, I dedicate 72. So as you can see on client 3, I also configured the network interface to be on VLAN 72. Okay. Alpine might have started already. Of course it has. And I will log in. As you can see, I've configured just this static 2 address to be my primary for the Ansible controller to reach it. And I have nothing installed on here like NFT or DNS mask. It's just an empty environment. In order to fill this up with a configuration, we will head over to my Ansible controller. This is my Ansible controller, and here we have the playbook. My host name is alpine1.demo.unicast.de, and here we have some roles. Those are all my roles. I wrote them all by myself, and most of them are very basic. Only netconfig and especially nftables is where most work went into it. But let's go through them. Message of the day, that's mostly cosmetical but helpful. Host variables go into it. Ansible facts go into it. This will set up the repository to latest and also choose a near mirror. Then this CTL is going to set some kernel parameters like accept router advertisements and stuff like that. At first I chose router advertisement daemon to use as root advertisement daemon, but then I switched over to DNS mask because this software can solve a lot of problems at once. It acts as a DNS server, it acts as a DHCP, DHCP v6, root advertisement daemon, all that stuff just in one software. Very smooth. You might know it from other projects like OpenWRT, which is also a very beautiful solution. I suggest to try it. Then this is setting just a resolve-conf. This is giving some SSH public keys into my host, setting the time zone to my specific time zone, of course. Installing some general packages I like to have, like nmap, tcpdump and stuff. Ansible netconfig is setting the network configuration of the interfaces. I'll show you more about that just in a minute. And the most important one is Ansible nftables, which is the role to set all the nftables rules for forwarding, for input, rejects and drops, logging and so forth. We will dive into that later. All these rules I publish on GitHub. Check link down below. And you can also find them on Ansible Galaxy, of course. All right, let's have a look at my host variables. Here we go. So first, net interfaces. This is the role that sets all the network configuration interfaces. This is the role that sets all the network configuration on Alpine in etc network interfaces. So of course, yeah, this is my public interface and this is my private one. Okay, regarding the public interface, I set it on DHCP for IPv4. I'm not going to use it very much because I'm using IPv6. And that's why I set the method 6 for my public interface to static and choosing to set an IP address to a static one. On top of that, I chose to set the kernel to drop router advertisements. For my private interface, I also, of course, reject router advertisements because I'm the one sending out router advertisements. I also set the IP addresses for IPv4 and IPv6 as well to static. Here is the DNS server setup. So this is going to etc resolve-conf, and those are just Hurricane Electric DNS name servers, and this is my domain search path. This is message of the day. Settings, but this is not so important. What I would like to show you, which is the most important thing, is about nftables, of course. The nftables role you can set either to firewall or to server. In the server mode, you can have 1, 2, 3 interfaces, but you're not gonna forward the packages. You just have inbound packages and decide whether you drop or reject them, or maybe even accept them. When you provide services, you obviously want to accept at least some of them. But here we are running on firewall mode because we also have multiple interfaces, but we are letting the packages go through from LAN side to public side, and sometimes also from the public side to the LAN side. We dive into that later. Then my default policy is set to reject. You might also want to set it to drop if you prefer that. And I enabled logging. This is a Boolean variable. Those are kind of global settings, all right? Next is nftables masks. If you have plenty of IPv4 addresses, then you maybe just don't want to do IP masquerading. But in my case, I would like to use IP masquerading. With IPv6, this is not necessary, as you might think. Let's go down a bit further. This is nftables host variable. There is also nftables open group. Which one you take depends on the Ansible use case. If you decide to do some firewall adjustments to one single host only, then you have to choose nftables open host. This host refers to the Ansible environment. And you might also operate some more firewalls, and some of them fall into a specific group, let's say for some specific site. And then you can use the nftables open group variable and set it to some specific values, and all the hosts that belong to this specific group will inherit the settings. But here in my example, I have only one host, and we are setting some firewall rules on this one. For example, this is a rule that allows to receive DHCP requests. Another one is port 53 for DNS, of course, and opening it up for both IP families. On the one hand, for TCP, it's hardly used, but mostly it's UDP, so there is another rule for UDP opening. And here we allow, oh, this is bullshit, of course. Yeah, I opened up port 547 for DHCP v6 on family 4, which is bullshit. So we changed that, and I opened up SSH for my public interface for a specific prefix given down here. This is the source address directive. There is also destination address, but I'm not choosing to define one here. Down below we have nftables forward. There's only one example given. So in this case, I'm accepting everything coming on ETH0 with a destination address of this one, which is my local interface. This is my local prefix for all my clients on the private interface, and this is just some random public interface, so you guys can see an example. And I would like to open port 22 for TCP. So everything that's coming from the internet, going through my router to my private network, and is trying to do SSH, is being allowed with this one. For IPv4, you could also do a forwarding if you have public IP addresses and you don't choose to use IP masquerading. But in my example, I'm running a firewall with only private IP addresses generally. In my example, I'm running private IP addresses, so I need to do a DNAT. And meaning if traffic is coming in on the public interface and going onto the public facing interface of the firewall, using destination port 801 and protocol TCP, this is being redirected. I mean, this is not redirected really, but it's just a destination net. Here at the end of the file, there is some DNS mask options. Just take a look at them. It's a setup of the DHCP server, also DHCP v6, and route advertisement, of course, is also running. Yeah, well, let's run it. This is going to take some time. That's why I'm trying to comment on what's happening. At first, the message of the day is being set up. This is just cosmetical stuff. It's not so important, but there are some things that are going to be set up that are important for a firewall to function. Here we have a repository set up to a local mirror and to a latest stable in my example. Then I set kernel parameters to a specific value to accept route advertisements. In my case, I actually don't accept them because I set them to 0. Okay, this is a kernel parameter. On both interfaces of the firewall, they are being rejected. Then I would have to enable IPv6 forwarding, as I did here with IPv4. I choose to use DNS mask as a solution because it's very good, it's tiny, and it is quite powerful. Yeah, what's next here? DNS mask interface specific configuration, start DNS mask. This one is setting just the DNS server, which is also being used for DNS mask, and local clients who ask the firewall for a DNS name, the DNS mask is going to use the resolve conf entries. In my example, you might want to set it you might want to set it up differently. There is a bunch of SSH public keys that are going into, this is not so important. Installing some packages, nmap, TCP dump stuff I often use. And here we're going to deploy the network interfaces. Next up is nftables. The rules are being set. There are some sanity checks here. If the variables are set to something like family 4, something like family 5 wouldn't make sense, and the playbook would be killed. And yeah, it's quite finished. Network interface is being restarted and the nftables rules are going to be set. So let's have a look at the firewall itself. Isn't that nice? Beautiful. This is the way. In order to be able to look at the firewall rules, I need to be privileged user, but at first we are looking at the interface configurations. As you can see, it's been set up perfectly. We have default routes, everything we need to go online. Name resolution is working too, as is IPv6 connectivity. And here we go with our nftables rules. Let's have a look at them. This is a pre-routing chain, and this one is being used for destination net. This is being redirected to this host. All right, post-routing. Here's a slight error in it. Let's correct it. It's a small bug I will fix. This is the wrong interface. My public interface is ETH0, so let's just quickly load it. Okay. As you can see, it's been adjusted. And next is the input chain. So this part is general input. Packets coming into the firewall which are destined for the firewall, not for any other host. This is the input chain, and this is the unspecific input chain. We also have input chains that are specific to the packages that enter on specific interfaces. I'll tell you more about that later, but let's look at the general interface section. Here we have only one specific rule setup allowing SSH to the firewall when it comes from this specific host. And here we have the jump points for everything that's interface specific. So this one says if the packet is coming in on interface ETH0, let's jump to input chain input ETH0. But first we have a quick look at the forward chain. Here we have some rules that define what happens to incoming packets that are not destined for the firewall, but are for some other host the firewall can route to. Okay, this one here is for all traffic that comes from my private interface and going to the internet. Okay, the incoming interface ETH1 is for my clients, and the outgoing interface is ETH0, which is going to the internet. And this is being accepted. You might want to choose to set it differently, but this is my general policy. But for packets that are coming in on interface ETH0, which is the public-facing interface, it should generally reject. This is why we have a reject in the end. Those are being auto-generated from the DNet rules. Down below we have our interface-specific sections. So those are rules that are only being applied to everything that's coming in on ETH0. So we have some SSH being allowed. This is again being automatically generated from our DNet rules. And on the other side, we have a specific chain for everything that's coming in on ETH1. It's a little bit hard for me to speak so much English. I'm not very accustomed to it. My main language is German, and please excuse my flaws. Not my flaws, but my flaws. All right, just have a look at them. Those are some basic rules allowing DHCP, DHCP v6, allowing DNS for all my clients. So we might want to look at the client. Here we go. Client 3 is connected to the connected to the LAN interface of my firewall, and we do have an IP address. Can we reach the internet? Yes, we can. Can we resolve hosts? Yes, we can. And as you can see, we have also IPv6 connectivity. So we have a default route being laid out on ETH1. And yeah, that's it. I mean, as you can see, it didn't take me very much time. Just define some variables, use the playbooks, but everything is described in more detail in my GitHub repository. Right now, this is only a bunch of Ansible roles. I haven't made a collection yet, but I'm going to. All right, I mean, the client is working. You might want to try it out. This is not ready for production purposes yet. It's being developed very actively right now from me only. If you want to participate, just ask me. I'm on GitHub. And you might want to put some suggestions or comments in the section down below. So I hope you enjoyed it. I hope you can make use of it someday. And see you next time. Bye bye, guys.